Great day, learners! Welcome to another fun and interesting math learning experience. What are you waiting for? Grab your pen and paper, your self-learning modules, or your compendium of notes, and together, let's rock math. This week, we will further our learnings about rational exponents, and this time, we will write expressions with rational exponents as radicals and vice versa. Are you ready to learn about that? And if you are, let's unlock another math knowledge. First, let's recall our understanding about radicals. A radical expression is an algebraic expression written in the form nth root of a. We have here some algebraic expressions. First, square root of 15, cube root of 28, fifth root of 64, and fourth root of 32. As you can see, these are all written in the form nth root of a. Therefore, these are all radicals or radical expressions. A radical or a radical expression has three parts. First is the radical sign or the radical symbol. Under the radical sign, we have the radicand. And also on top of the checkmark portion of the radical sign is called the index. Now, how do we convert expressions with rational exponents into this form? We can convert expressions with rational exponents into radicals in two ways, and this is made possible by applying the rules of exponents. First, we have here a raised to m over n, and that is equal to quantity a raised to 1 over n raised to m. And in radical, that is quantity nth root of a raised to m. Let's have our second one. We have here a raised to m over n, and that is equal to quantity a raised to m raised to 1 over n. And in radical, that is nth root of a raised to m. If you can notice the movement of our rational exponent, which is the same for both the first and the second one, our numerator becomes the power, and the denominator becomes our index or the root of the radical. Now we have to remember this rule, as this will make it easier for us to convert expressions with rational exponents into radicals. Let's see and apply this in our examples. We have here our first example, 7 raised to 2/3. As we have said earlier, the denominator of the rational exponent will become the index or the root of our radical. And the numerator, which is in this case is equal to 2, will be the power. Therefore, if we convert 7 raised to 2/3 into radicals, this will become the quantity cube root of 7 raised to 2, wherein 2 is the power and 3 is our index. Or this can also be the cube root of quantity 7 squared. Next, we have 8x raised to 2/5. If you can see, the rational exponent 2 over 5 is only applied to x. So we can only convert x raised to 2 over 5 into radical. Therefore, 8 will not be a radicand, but therefore a coefficient. And converting this one, the power will be the denominator, which is equal to 5, and the index or the root of the radical is the numerator, which is equal to 2, and that is 8 times the fifth root of quantity x squared. We have here our third example, x raised to negative 3/2. Before we convert this into radical, let's first take the definition of negative exponent. So x raised to negative 3/2 becomes 1 over x raised to 3/2. Now we can convert this into radical, wherein 2 will be the index and 3 will be the power. Thus, we have here 1 over square root of x cube. Remember that for radicals whose index is 2, we don't need to write 2 on top of the check mark portion of the radical. Next, we have quantity a squared plus b squared raised to 1/2. As you can see, a squared plus b squared is entirely raised to 1/2. Therefore, a squared plus b squared will be our radicand, wherein 2 is the index and 1 is our power. So in radicals, this becomes square root of quantity a squared plus b squared. And for our last example, we have here quantity xy raised to 2/3. Same as in example number 4, xy is entirely raised to 2/3. Therefore, xy will be our radicand, wherein 3 will be our index, and 2 will be our power. So in radical form, this is cube root of quantity xy raised to 2. We apply the power of a product rule inside the radical. Therefore, this will become the cube root of quantity x squared y squared. And that's it for converting expressions with rational exponents into radicals. This time, let's do the opposite. Let's convert radicals into expressions with rational exponents. In converting radicals into expressions with rational exponents, we have this rule. Let's observe the movement of the index and the power when it's converted into expressions with rational exponent. As you can see, the index n of the radical will become the denominator, and the exponent or power m of the radicand will become the numerator of the rational exponent. And that is how we can easily convert radicals into expressions with rational exponent. Let's see and apply this rule into our examples. Our first example is cube root of b. Let's determine the index and the power of this radical expression. The index of cube root of b is 3, which will be the denominator of our rational exponent. And the power of the radicand is 1, which will be the numerator of our rational exponent. Therefore, if we convert cube root of b into an expression with rational exponents, this will become b raised to 1/3. Next, we have square root of 10. What is the index of square root of 10? It is 2. Therefore, 2 is the denominator of our rational exponent. How about the power of 10? The power of 10 is 1. Therefore, the numerator of the rational exponent is 1. So if we convert square root of 10 into an expression with rational exponent, this will become 10 raised to 1/2. Our next example is the square root of quantity 2ab raised to 5. For this one, what is the index of this radical expression? The index is equal to 2. Therefore, 2 is the denominator of our rational exponent. How about the power or the exponent of the radicand, which is 2ab? It is 5. Therefore, 5 is the numerator of our rational exponent. Thus, if we convert square root of quantity 2ab raised to 5 into an expression with rational exponent, that is equal to quantity 2ab raised to 5/2. Our next example is the cube root of quantity 125a cubed b raised to 6. Again, let's identify the index and power of this radical expression. For this one, what is our index? The index is equal to 3. Therefore, 3 is the denominator of our rational exponent. How about the power of the radicand, which is 125a cubed b raised to 6? The power or the exponent of our radicand is equal to 1. Therefore, 1 is the numerator of our rational exponent. Thus, if we convert cube root of quantity 125a cubed b raised to 6 into an expression with rational exponent, it will become quantity 125a cubed b raised to 6 raised to 1/3. Let's apply power of a product rule, wherein we will distribute our rational exponent 1/3. It will become quantity 5 cubed raised to 1/3, quantity a cubed raised to 1/3, quantity b raised to 6 raised to 1/3. 125 was rewritten as 5 cube since 125 is a perfect cube. Now let's apply power of a power rule. This becomes 5 raised to 3 over 3, a raised to 3 over 3, and b raised to 6 over 3. We further simplify, this becomes 5ab squared. We have here our last example, quantity square root of 3a squared plus 4b squared raised to 2. As you can see, the radical expression is enclosed and raised to 2. Therefore, we have to focus first on the radical expression inside the parenthesis, and let's convert that into an expression with rational exponent. So for the radical expression, what is our index? Our index is equal to 2. This means that 2 is our denominator in the rational exponent. How about the power or exponent of our radicand? The power or exponent of our radicand 3a squared plus 4b squared is equal to 1. Therefore, 1 is the numerator of our rational exponent. If we convert this, this becomes quantity 3a squared plus 4b squared raised to 1/2 raised to 2. We apply power of a power rule. This becomes quantity 3a squared plus 4b squared raised to 2 over 2, or if we further simplify, this becomes 3a squared plus 4b squared. Now that we are done converting, let's wrap up this session through a quick recap. In converting expressions with rational exponent into radicals, we have this rule. A raised to m over n is equal to the quantity nth root of a raised to m, or nth root of quantity a raised to m. On the other hand, in converting radicals into expressions with rational exponent, we have this rule. The nth root of quantity a raised to m is equal to a raised to m over n. It is important to remember these rules, as these rules will help us easily convert expressions with rational exponent into radicals and vice versa. That's it for our lesson this week. I am hoping that you have learned from this week's session, and this will help you answer and ace your activities. If you are still struggling, you can always rewatch this video and continue practicing until you can do it. Anyway, this has been Teacher Mark saying that math matters.